everybody. Hope you are doing well. So this week is about gas law calculations. Last week you investigated the changes in pressure, temperature, and volume with gases. This week let's do some actual quantitative calculations. Okay, so the ideal gas law gives us this equation. P is pressure, V is volume, N is the number of moles, R is a gas constant, which is given to us, and then T is temperature. Each of these items in this equation has got a certain units to it. Pressure can be in three of them. It can be in atmospheres, it can be in what's called bar, or it can be in what's called torr. Volume is always in liters. N, the number of moles, is just in moles. R is the one that is special. I'm going to talk about that in just a second. Temperature, T, is always in Kelvin. So take a look at that for just a second. All right. R. There are three different gas constants. Each gas constant has a particular pressure. So I've got a gas constant for atmospheres, one for bar, and one for torr. My gas constant for pressure in atmospheres is 0.08257. For bar, it's 0.08314, and for torr, it's 62.36358. People did experiments to calculate these gas constants so that we could calculate between these different terms. Pressure times volume equals the number of moles times the gas constant times temperature. Okay, so when you do these problems, we have to make sure that we are using the correct R value to match the pressure. So let's work out a problem. If I am given a balloon and I want to find the pressure, and I want to specifically find it in the units of torr, that balloon's volume is 2 liters. I have 1.5 moles of the gas inside the balloon, and the balloon is at 290 Kelvin. I can figure that out using the ideal gas law equation. I'm going to fill in our numbers. The pressure is what I'm looking for, so I'm just going to use the P. My volume is the 2.0 liters. That equals N, my number of moles is 1.5. My R value. Now I got to pick my R value. I don't know which one to pick. I want the one that's in torr because my problem asked me for the pressure in the units of torr. So I'm going to use this big old number, 62. So my R value is 62.36358. And now the last thing I need to fill in is my temperature. And the temperature my balloon is at is 290 Kelvin. Okay, so I'm not going to do that in my head. I'm going to go get a calculator. Actually, I already did it out. There's my calculator. I'm on the ball. Okay. When you work this out, you are going to have to do a little bit of rearranging like in algebra. So I'm going to do that now. My P here, I need to solve for pressure. So I'm going to take my 2, I'm going to divide this entire side by that. So P equals 1.5 times 62.36358 times 290. Going to divide that whole thing by 2.0. And when you work that out, and I rounded to my one significant digit, your answer is big. 13,000 564.1 torr. Okay, so give yourself a pat on the back. Box your answer in pretty pink. And then you have solved one ideal gas law equation. I'm going to leave this up for a second so you can look at it. The key to these problems is making sure that you match the R value to the units of pressure. And these units of pressure, people in different countries and in different disciplines like engineering versus weather, they put their pressure in different units. But everybody does temperature in Kelvin and volume in liters. Okay, thank you guys. Yeah, I miss you. Hopefully you're all doing well, and contact me with any questions. And remember, come visit me in my virtual office hours every afternoon. Check the stream. Bye, guys.